Okay. Is it a hump or a drop? What do you say? You've got to twist your words in every which way, because the model will always dictate what you do. Everybody knows that you've got the model affliction blues. Is it a straight line, or does it curve? Some people don't clamp it, but that is absurd. We all know that the model dictates what you do. And everybody knows that you've got the model affliction blues. Model affliction, it's your addiction. Model affliction, it brings you so much pain. It's your ball and chain. Conflating curvature with elevation change. Just got your local distance just out of range. That oblique is gonna dictate everything that you do. And everybody knows that you've got the model affliction blues. Model affliction, it's your addiction. Model affliction, it brings you so much pain, and it's your ball and chain. It's your decision defending the model position. You just don't know the geometric proposition. That old ball will always be illogical to you. That's why perpendicularity is a puzzle to you. Model affliction, it's your addiction. That old model affliction, it brings you so much pain. It's your ball and chain. And everybody knows that you've got the model affliction blues. Works really good with this guitar. Is it a hump or a drop? What do you say? You got to twist your words in every which way. We all know that the model dictates what you do. Well, we know you got it, the model affliction. Model affliction, model affliction, model affliction, Well, we know you got it, the mild affliction blue.
And we are live. Welcome, everyone. Model Affliction Blues. I don't think I played that one for a bit. That was the original. Welcome. And seeing as we're wrapping up the end of the year for me, we're going to go into the nut sacking, the final run. We're going to go over tonight. This one show's called Differential Differences. We're going to go over a bit of about the closest we could get to a surveyor, because all of the other surveyors, well, the role-playing surveyors, they all left the arena. Talking about Jesse Kozlowski and the guy that probably doesn't live in Maine. He's not come back around. There are a few of them around here, but what we're going to go over tonight is George. And let's have a look, see whether I think we got a few. So much happens over the weekend. Well, we got a few 27th of March. Oh no, yeah. This morning. Jesse Gordon. And runners, you want to run us by these? Was going over this morning. We got our who's the math heads here. Right, so we're going on for these things this morning. Stark Odder, I noticed, he corrected Blue Marble Science. When Stark Odder has to come out and correct Blue Marble Science, you know you're onto something. So Stark Odder says zooming doesn't change the angular size of objects. Those remain the same, always. What changes is the angular field of view. So the relative size of the object within the field of view is what changes. So not the actual angular size of something. Says Stark Odder. And then he says, I say, are you sure about that? He says, the angular size of an object is determined by its size and the distance to the object from the observer. That's the angular size of the object, right? So in order for you to know the angular size of the object, you need to know the size of the actual size of the object and the distance it is away from you. He says it's simple geometry, so not surprising you're confused by it. Right, so that's how we know the angular size of something. We have to know the distance it is away and the actual size of the thing. I don't know why we need to know the angular size of it if we know the actual size of it and how far away it is, but these are the games that we're playing. And I say, you should tell that to Ruhif. He's called himself Roofy now. Sounds intelligent. Just bear that in mind, right? So keep that in the back of your mind, that the angular size of an object doesn't change ever. And okay, you just need to know how far away it is. This one, Jesse Gordon, he's talking to Rakia and Brad Leakey. Also, here's a day where I measured the angle to the horizon at different heights on a day when it was showing above eye level. Horizon. This is Jesse Gordon. Here's a day where I measured the angle to the horizon at different heights on a day when it was showing above eye level. That's the horizon. And the attached picture shows the same view from the same location, but on different days, when one horizon showed above eye level and one horizon showed below eye level. And then he's got this here picture. And he's got a video. Jesse Gordon. He was promoted by Jesse Kozlowski. The guy that did a Jesse Kozlowski isn't around anymore. Stark Otter says, and I think I know what flat earth test Brian is referring to. Using the focal length used and the size of the pixels or something, you can calculate the image scale of the image. But you can also get the image scale by measuring a known angle in the image. And then I put Ruhif, and Ruhif says here, he 100% agrees with Stark Otter that the angular size always stays the same. And I say, I expected contradictions. And he says, what contradiction are you referring to? And then they're talking about a camera. And that gives an image scale and then of so many arc seconds per pixel. Does that match your measurements in the image? So the measuring angles from within an image. And the image is like that. It looks about right. And then Ruhif or Rufy says, hang on. I get the reciprocal of that, i.e. 5 arc seconds per pixel. That's per pixel. You remember when George was saying about the crosshair? It was 2 arc seconds. So we've got an arc second that's thinner than the pixel within the image.
Pixel geometry. Wow.
Well, if you go back to this bit here, right, it says zooming doesn't change the angular size of objects. Those remain the same, always. What changes is the angular field of view. So the relative size of the object within the field of view is what changes. And you only know the angle because you know the distance to the object and the height and the size of the actual object. So that's how you know the angular size of the object. But it doesn't change, even though it'll definitely be different than these angles that they're getting in 5 arc seconds per pixel. In real. Because the angular size doesn't change. So Ruhif knows that the real size of the mountain is about 5 arc seconds per pixel. That's handy to know. Because that's how you measure mountains, isn't it? What's the angular size of that mountain? It's about 5 arc seconds per pixel. Ruhif's worked it out. Doesn't change either.
Pixels.
Yeah, it doesn't. It doesn't change.
Yeah.
Well, it might change because it depends on the size of the object and distance you are away from it. So if you move, then yeah, it'll have to change. But I mean, it doesn't change with the picture once you've got a picture. But
depends on pixels.
Yeah, you can put a line on a picture and call it an angle. Ruhif's been doing this for quite a while. I mean, everybody's been knowing about that. It's one of the special things I've been working on, really. Wondering how people can imagine and go along with Ruhif and his fantasy, putting rulers on pictures, calling it an angle measurement. When you know, and even Starkadder knows it, it's here. You have to, the angle size stays the same, determined by its size and the distance. So if you don't know the size of the thing or the distance, then you can't work out the angular size of something. And when you're talking about 5 arc seconds, it's a bit of a... I don't know, anybody know about the rules of trigonometry? In reality, of course, not just mathematical trigonometry, but reality trigonometry. Would you trust a measurement of 5 arc seconds and a distance of about 200 miles? Doesn't sound proportional, that triangle, to me. But that's what these people are doing. Can't get away from it. These are the superstars of this arena. And in saying that, I'll go back to the live chat. We are going to go over. Let me get this. This is... I'm going to have to get into this because this is a big, long video. Really long. 4 hours. But, I mean, if everybody's missed George, here's your chance. You can get a bit of George back again. And if anybody wants to know who George is. Now, George is... well, I think he claimed to be the mathematics genius, but he has some strange views on pi. So, George is the guy who did the Rainy Lake thing that Walter Bislin's now got. Took it off George. I don't know whether he credits George for it anymore or whether it's just Walter Bislin's Rainy Lake. Which George touted as an advanced Bedford levels thing, which he got a concrete pole in the thing. Anyway, so George is in this one. We've talked him through, and he's come in to explain to, I think he was explaining to Mobius. Blue Marble sent George over because Mobius was asking him, you know, since George was the man. And I think Mobius was asking Blue Marble, and Blue Marble said to Mobius, you'll have to ask George, and I'll get George to sort it. So George is coming over to speak to Mobius. Now, we've already had the snowflake rule in place because George gets really upset. So we want George to go over this thing, and he's prepared these slides. And this is George taking us through how differential leveling would have to work on his dogmatic globe model. It's not a comedy thing, this is deadly serious from George. And this is, I think this is what we call this the nut sacking. It's when you go too much into a model and the model starts dictating everything that you're thinking of, especially when you think you're a mathematical genius. This basic geometry. I think there's a little bit where I play just to catch up to at the beginning. So, is everyone all right with that? Not got anything? Does anybody want to go over anything first? No? Okay. Here we go then.
From your auto level, as you use that angular measurement, you multiply by the distance to the target, and that tells you the amount of uncertainty in your vertical measurement. So for example, if you have a 1 arc second auto level at 100 meters, you can expect an uncertainty of about a half a millimeter. That's what 1 arc second works out to. You'll have an uncertainty in your vertical measurement on your measuring rod or whatever of a half a millimeter. You can't, even though you could read it to better than that possibly, but you can't say for certain that that is what it actually is. With a perfect auto level, with no inaccuracies, yeah, what you read on your story pole is what you're getting. But every instrument has a certain amount of uncertainty associated with it. So with a 1 arc second auto level, the best you can say is, say you read 12.6 millimeters on your story pole, but you can't say it's actually 12.6. It's 12.6 plus or minus a half a millimeter, because the auto level will not allow you to, it has an uncertainty of 1 arc second, which works out at 100 meters to be a half a millimeter.
George, I don't want to interrupt. You've been going on for 2 minutes. Please conclude and let him respond. Please, George.
I just did.
Oh, I'm sorry. Okay, bad timing for me. All right.
Okay, well, I'll say again, an auto level just doesn't measure vertical angles, so...
I didn't say it did.
Well, I'm saying as well, if you get the most accurate auto levels, then they read to 0.01 of a millimeter. Well, that reads to 0.01 of a millimeter. No mention of angular measurements or anything.
But that's a meaningless number. At what distance?
0.01 of a millimeter is a definite
But at what
number.
distance? At what distance?
At 30 meters.
But
I don't know whether I've said that loads of times. If you want to keep the most accurate you can, you come down to 30, 40 meters maximum, and you fit a micrometer to a precision level. Very costly shit. But you can do that.
What's the numbers you have now? Point what? 0.01 millimeter?
I put it in there before.
No, just give me the numbers. Just tell me, what are you claiming?
A precision level measures to 0.01 of a millimeter.
Okay. At 30 meters, you're saying?
Yes. It's going to be a problem for you, I know, George, because you're going to do some calculations and say, oh, you can't. But, I mean, it's not me.
No,
that
you
writes
can't.
this. These are the tools.
You can't.
You can't.
No, not with a 1 arc second.
It's not arc seconds.
Yes, it
Auto
is.
levels do
Look
not
at your
measure.
do you have a manual?
George.
Do you have a manual? Do you have a manual for your auto level? Look at the accuracy setting of the compensator. The setting accuracy of your compensator. See how it's rated. Dig out your manual.
There you go, George. Just have a look for yourself. It's a big job, isn't it? Preparing. Oh, welcome, George. Oh, George has just arrived. Yeah. We can hear you, George.
Hi there, Bill.
Yeah. I've just got back. Mobius was saying something about you. You've got a presentation for him. He's been asking.
Well, I don't know. He wanted me to talk about differential leveling. I don't really care to, but I did give him some information yesterday. I don't know. It's not really necessary.
Do you not know that much about it?
No, I didn't say that. I mean, I can talk about it, but is it going to be really of any value? You seem to say you understand differential leveling. You can tell them.
Mobius was asking you though.
Mobius is what?
He's a curious young lad. He wants to get as much. He wants to gain as much information about everything as he can.
All right. Is he here? Oh yeah, he's there.
Yeah, I think he's around.
I think he just popped away for a minute.
I did ask you, Bev. I wanted to know what is the make and model of your auto level?
Datum.
What, datum?
Yeah.
DATUM?
Yep.
And what model?
AL 32.
AL 32. Okay.
There's a link on the website.
Which website?
Which website?
You said on the website. What
Yeah,
website?
the On the Level website.
Sorry, I was on mute. I didn't want to interfere too much in VC, so.
There's no interference. What is it that?
Well, I was just hoping that maybe you could go over some of the stuff that we were going over in text, in DMs, because I still have some questions, and I figure if you explain it
All right.
to other people, then they can maybe get a better grasp on it than I was.
Well, that's up to Bev. This is his deal.
Yeah, I think we were all in agreement that you could go ahead and do present what you had presented in DMs with me, and everybody'd stay on mute and just let you kind of have the show.
Is there? It would be better if I could live present, so that I can manipulate the graphics around a little bit rather than keep posting it and having to change it and then posting it.
Can you not do that already, George? Has it not got the video and the screen at the bottom of the screen?
Where?
Can you not do that?
Well, I suppose I could. I mean, if you're with your permission.
Yeah, if it's on the screen there, then yeah, you can. Like if it's there, you should.
Okay, hang on. All right.
So. Yeah, like either a live stream or share your screen, however you want to do it, I think. Oh, yeah, there you go. Perfect. All right, I'll go back on mute.
Holy crap! Hi, George.
I've got spinny blobs though.
Okie dokie.
Yeah, it's just a spinny. No pictures coming up.
It's up for me. I can see it.
Is it?
You
It's
can.
I
I can't see it either.
It's the no. It's the first bit. It's the two green lines. It was working.
Oh, it wasn't for us.
Buster, it was not.
Yeah.
I swear.
Why did you say hello?
Maybe George, you could try that again. Did he leave?
Yeah.
Oh,
No, I swear. I could see what he put up. I was looking at it.
Oh.
So what? Is there a problem?
No.
Well, maybe you could do it again. I wasn't able to see it, but Buster says that he was able to see it.
Yeah,
So.
I couldn't see it.
You can't see it?
No,
Got out.
I wasn't able to before, but Buster said that he was able to. So
Did it,
maybe
did
it
it
was
kick you
on
out as
my
well,
part.
then, George? Because you're not sharing it anymore.
Huh. I don't know what happened yet. It's gone. Huh. Okay, let me try again.
It looked.
The screen went
It
off.
looked like. I'm sorry. It looked like you had it sectioned out, and like I could see the first bit. It was like two.
Well, I don't know. For some reason, it kicked me off. Are we there again?
There we go. Let's see.
You see it now?
Oh, yeah.
Yep.
I can
Yep.
see it.
Yep.
Yep, there it is. Perfect. All right, I'll go on.
Okay. I don't know. For some reason, it canceled me out. Okay. Well, we'll try
This
again.
looks good. This looks good.
All
What
right.
is this, George? That's
So-
good.
Okay, so what we have, the green are our two rods or our grading poles. You know, they'll have marks on it. You know, in the UK, I don't know what you use for graduations there, maybe 5 millimeters. What are your grading poles marked at finest resolution, Bev?
On the backs of them, you get millimeter on the back, but if you're after really accurate stuff, you got millimeters on the back.
Oh, so they will grade it down to a millimeter, huh?
Yeah, but really close. You know, you have to do
Yeah.
that. That's yeah.
Right,
You
of course.
you're
Yeah, in the
usually a
US,
centimeter or half centimeter.
yeah, in the US, they're generally marked in hundredths of a foot, which is about 1/8 of an inch.
Mhm.
So, okay, so these are our two grading rods in green. The auto level is the blue in the center here. And in differential leveling is the best way to do it. The easiest way is you set your auto level midway between the two poles. You don't have to for differential leveling, but by putting it symmetrically between the two poles, the curvature of the Earth drops out, and you also end up minimizing refractive effects, and I'll tell you why that's going to happen here in a bit. So you have your auto level set up, and now you can spin the scope around. You can shoot in this direction to the left, which we call the back sight, or spin it 180 degrees and shoot in the forward direction, which we call the foresight. Now, with the auto level set up and the compensator moving freely, you shoot a straight line, and you are guaranteed when you look through the scope of the auto level on the back sight to the left pole and read the mark or put a mark there, and then rotate and go around to the foresight and read your mark on the pole, that these two marks that the auto level is sighting are at the same elevation or at the same level. Level and elevation, if things are at the same elevation, they're also on the same level. That if you connected, say, a continuous line all at the same level, or at the same elevation, you put water in the trough, the water is just going to sit there. It's not going to flow. That's what we mean by the same elevation or the same level. But you are guaranteed, even if the auto level is out of adjustment, that if you sight a foresight and a back sight on the pole, that these marks will be at the same elevation. You're always guaranteed that with the auto level. Now, what I'm showing here is in black is, let's say this is our ground. Have a little, say, depression here, a little well, but this is our ground level. Now, the thin green line is a level line. That's just above the ground. And this would be, say, if you laid a hose along there. I know this is going to bother you because it's curved, but this is a level line on the earth that if, say, this were a hose and you filled it with water, the water would just sit in the hose. It would not flow. Even though you think it's on a hill or whatever, that's not the way it works on the earth. But and what you have...
Is everybody getting this? Like it's the first time I've interrupted. I don't want to interrupt George. Otherwise, Blue Marble Science might say I'm, or, you know, spoiling the flow. But this is George going over his way of solving the horizontal paradox. Get into any conversation with anybody about actually how surveying techniques are actually done in reality. This is what the Blue Marble scientists do. I'm pretty sure George must have done this for Blue. Blue sent George over to help Mobius out. That's what this is. This is George showing Mobius how differential leveling works on the globe model. We all know how it works in reality, but this is George going over on the dogmatic globe model. I'll let him continue. That's level, right?
When you shoot these two
On the
marks
globe.
on your pole, if I were to
Dogmatic
say, see, measure the distance shown in yellow from where the odd level is sighting on the pole to a level line on the ground. And I look on this one too. The distances are guaranteed to be the same, even though the Earth curves away from the odd level in both directions. The fact that the odd level is in the middle, we get the same drop distance on the right here as we have on the left here. And what that does is, in differential leveling, this is a differential. We're comparing one side to the other side. Whoops. And we are guaranteed by symmetrically placing the odd level in the middle that the drop distances to where it sights on the pole is the same on both ends. So the Earth curvature ends up not being an issue. It drops out of the equation because we are guaranteed that these two sights, these two marks, are at the same elevation or the same level. It doesn't matter whether you're on a flat Earth or a curved Earth or whatever, because of differential leveling. That's the beauty of differential leveling, is the Earth curve drops out and it doesn't affect your measurements at all.
So you get that? Earth curve just drops out. So remember that when using differential leveling with the horizontal plane, Earth curve drops out.
The other advantage of doing this is that when you're sighting, say, in the back sight, the amount of refraction that you pick up is the same as the amount on the foresight because you're symmetrically placed. The atmosphere changes the same in both directions. So if you pick up refraction looking on your back sight, you're going to pick up the same refraction on the foresight and it cancels out. So in differential leveling, you have two advantages, is you minimize refractive effects and the curvature of the Earth does not affect your measurements. Now, let's...
Okay, so I'm pretty sure everybody's heard this one before, but George is just adding another one, that if you turn around, you can get rid of refraction too. They cancel each other out. Yeah. Same both ways, and the error cancels. Blue Marble's confirming it. This is exactly like it has to work on the dogmatic globe model. Thank you for joining us, Blue. Yes, Kevin says. Okay, here we go. Refraction cancels out. Brilliant.
Magic trick works.
Yeah. It's even if you've got like refraction going down in that direction and a refraction going down in that direction, they both just cancel each other out. They're both down. Down and down. Just makes it normal or something. I've not got a clue. But there's no refraction over these distances. You're not dealing with refraction. If you've got refraction in like a 50-meter run,
that would screw whole measurement.
Yeah, you don't want to be messing about with that. That's some pretty bad conditions. I wouldn't be surveying if you get refraction over 50 meters. So yeah, 32 times scope auto level. Right, here we go.
Let's look at Any questions on that? Hello?
Have you got a fish tank in the background there, George, or something?
A fish tank?
Yeah.
What do you mean?
It just sounds like you've got like some water filling up or something. Is it?
Oh, you mean the noise?
Yeah, yeah.
You mean the noise? Oh, that was the furnace fan kicking on.
Sounds like it turned off anyway.
Mm-hmm.
Yeah, it's off. So are we good on that part now?
Well,
I'm just going to reserve all my questions for later because I don't want to interrupt the flow.
Well, you can at this point before I bring up the next graphic.
Did you say it didn't matter about the level being out of adjustment or something?
Oh, yeah. If your auto level is out of adjustment, you are guaranteed that when you do a backsite and a foresight, that you're going to hit the same elevation on both. Now, you don't want to do that.
See? Even if it's out of adjustment, it's the same. It cancels each other out. It's brilliant, this. Just turning round. Doesn't half cancel loads of stuff out. Gets rid of curvature. It means you don't even have to set your auto level up or anything.
Maybe you should turn around auto level many times.
Yeah. Perhaps
to
you
be
should do it
sure
when you're
that-
taking pictures as well.
Cancel everything. 10 turns and you cancel everything.
Turn around, take a picture in the opposite direction and cancel it out. It'll be fine. Get rid of refraction and everything in pictures. Really close, really good.
Okay. This property is useful, say if you're going to do a two-peg test to check your auto level, is all I'm saying is, let me back up here, it's important to have your auto level and adjustment for doing the differential leveling as we proceed to the next step. Yeah. But if all you wanted to do was to sight and get the same elevation on two poles without moving the auto level, you put it in the center, that you are guaranteed, whether it's out of adjustment or not. It could be shooting high, it could be shooting low, but it's going to shoot high or low the same amount on the back sight and the foresight. And that would be your first step in a two-peg test, is you want to have two marks that are at the same level or at the same height in order to check your auto level. I probably shouldn't have even said that.
Right, is everybody clear on that, Blue? I hope you are. I hope you've got that sorted on how to do the first step in the two-peg test is to do a backside and a foresight, and it doesn't even matter if your tool's level or not. Doesn't matter. Cancels each other out. George is the best. I mean, let's carry on.
Let's just discount that. We're assuming that your auto level is on because we need it to be adjusted properly in order to do differential leveling and move ahead on taking it in steps. Okay.
Okay. So
I wasn't trying to imply, Bev, that you can do this with your auto level being out of adjustment. That's not what I was trying to imply. All I was trying to say is that even if the auto level were out of adjustment and you did a backside and a foresight where you're set up in the middle, you're still going to have the same elevation where it hits the poles. Oh God, yeah, I'm sorry. I probably shouldn't have even said that.
Yeah, don't worry about that. Let's just assume as we're going forward that you can't adjust an auto level, and the auto level is set, calibrated, horizontal. We've already done our two-peg test. We've checked it. It is indeed calibrated, right? Then
Correct.
We don't need to worry about how, if it's out of adjustment, because it shouldn't be, should it? It should always be bang on.
Right. Yeah. You want your auto level tuned in as close as you can to be giving you a horizontal.
Right, so we've just had to confirm with George that we don't need all of these checks, because we'll take it for granted that everybody knows how to do a two-peg test, and everybody knows that their tools are calibrated, and everybody knows that we've already done that and set it all up, because that's what we have to do first. And I'm not too sure whether everybody knows how to set up auto levels, but everybody in this room pretty much does, because I've shown everybody and we've actually done it live. I don't think George really knows how to do it, and I'm not too sure Blue's ever done one either. Blue said he hasn't ever done it. So anyway, the tools are set up correctly and always providing a horizontal. Here we go.
Okay, so here's differential leveling. This is what Buster was interested in. Okay, so what I put here in red is differential leveling with a symmetric placement of the odd level. One, it nulls the errors due to earth curvature, and it reduces refraction effects to near zero. I went through that. Okay, so let's say we start. We're going to move ahead in 3 steps with our odd level to try to do differential leveling. Now, the whole purpose of leveling is to transfer a known elevation to other places on the earth. Is you set up a reference, I'll call it R here, a reference elevation, and you just want to transfer it forward to other spots on the earth to establish places at the same level or the same elevation. Now, that's one thing that surveyors do, but they do much more than that. Particularly in this country where I'm at, people have a lot of hunting grounds and stuff, and they need to establish boundaries. In fact, the surveyors in where I live spend most of their time establishing boundaries rather than doing leveling. Construction companies have their own levels and that, and people that operate levels, and they don't need surveyors to do that. They'll be doing grading and leveling and stuff. But as far as surveyors go, professional surveyors go, their primary job around here is establishing boundaries, because that's a legal thing that needs to be established, and they need to be able to sign off on legal documents on property lines and stuff like that. So most of their time is used in establishing boundaries rather than doing a lot of leveling. But the differential leveling procedure is this. All right, we set up our auto level at position 1A. The black, again, the black thick line is the actual surface of the ground, okay? And this thin blue or green line here that you see is a level line that goes through M. M is our monument. Say this is a peg that we put in the ground that we know its specific height to it. The surveyors will call that a monument. And I'm saying, for just purposes of illustration, this monument, the top of the monument is 2 inches above ground level, and the top of the monument, point M, is at 1,180 feet 00 inches. That's about where I'm at here, above sea level. So that's our monument. Now, we want to transfer an elevation at R, which is at 5 feet or 60 inches above the monument. So from here on the monument, top of the monument, to this point here on the reference is 60 inches, okay? So what we want to do now is transfer this height or this elevation, say, as we move forward along the earth, we can do that. And this is how you do it with differential leveling. Okay, now we have poles. We have 2 poles, okay? This green pole and this green pole. This is our first step. We set our auto level in the middle, and we adjust the height of the auto level with the tripod and the Tribec adjustment screws on the base of the auto level, so we're shooting 60 inches above the monument. And we rotate our auto level around, and we shoot, and note the marking on the pole on the foresight. This is our foresight now. And the mark at A is going, we're reading on our pole 72 inches. That's in the pole readings here. So our first pole reading is 72 inches. Okay. And the reason why it's reading more than 60 inches is because we've got the pole set down in a hole. And this hole is about 12 inches deep. So the marking on the pole is not going to be reading 60 inches like it did on the pole here. It's going to read more, and by the depth of the hole that the pole is in. So we're reading 72 inches here. Now,
don't know why he put it in a hole.
But we know that point A is at the same elevation as the point R is, but the pole readings are different because we're on rough land, or we're on uneven land. And so the pole reading is going to be different, even though A is at the same elevation as R. So now we move our auto level ahead. Oh, before we move it ahead, again, it's midpoint. That is, the distance from the auto level here to R is the same distance as from the auto level to A. Okay, that's what we mean by midpoint placement or symmetric placement. It's absolutely imperative in order to drop out the earth curvature that the auto level be in the middle between the two poles. So now we move our auto level ahead a certain amount, and we measure the distance from the auto level to the pole, and then we can grab this pole here that we started with, or grab another pole and move it ahead in the foresight direction again. Now this pole becomes the back sight for this auto level position. We put another pole in that's the same distance away from the auto level as this pole is. So that again, we're in the middle. So now we have our pole set up. We swing our auto level. It doesn't matter how high it is, or the fact that it's on a hill or a depression. We don't care. All we're going to do is shoot the pole on the backside at B and note the reading on the pole. And B, let's say now, for sake of argument, we're reading 87 inches on the pole. It's above A. A was at 72 inches. We're now shooting the pole on the backside, and we're reading 87 inches. We swing the auto level around. Whoops, where'd that come from? We swing the auto level around, and now we shoot the pole on the foresight, and we sight C on the pole. And the reading on C is 74 inches. We can see that the pole is a little bit on a hill compared to where B was. B was down in the hole. So the reading on B is going to be higher because it's higher up on the pole than D. D's a bit up on a hill. So now we're reading, or C, we're reading 74 inches on C on the foresight. So again, by having the auto level set in the middle, we can say that the drop on this elevation here to a level line, that drop distance is going to be the same as this drop distance, okay? That the earth curvature is the same on both, so it drops out when we do a differential measurement, because basically what's going to happen when we're all done, we're going to be subtracting off these readings, and so any earth curvature drops out of the equation because we're subtracting it out. Now we move our auto level ahead now to position 3A, and we measure the distance from the auto level to this pole and set up another pole that's the same distance away. So again, we set our auto level up. It doesn't matter how high it is, and we shoot the pole here on the back sight to D. And again, the auto level is shooting a straight line to D, and we read D, and it is 77 inches. We swing it around 180 degrees, read the pole at E, and we're reading 81 inches. Okay, so now let's say we want to find what the elevation is of this black pole, the top of it at F is. We want to know what it is elevation-wise. So we have our measurements. Okay. The thing I didn't do here that surveyors have is a logbook, and they record all their back sites and their foresights, and I just wanted to kind of keep this simple without having a logbook, but Bev probably knows about it, and Mobius has probably seen them too, is you have a logbook and you record your back sites, your foresights, and then when you're done, you can compute what the elevations are by adding and subtracting the pole readings. And basically what you do is, if I want, since I know the monument is at 1,180 feet, and I know R is 5 feet above it, or 60 inches above it, let's find the height of F above the monument. The monument is our reference height. So we want to find out how high it is. Well, what you basically do is you take the reading that you start with at R, which is 60 inches, and you add your backside pole readings and subtract off your foresight pole readings. And that's what I'm doing here. For example, if you want to find the elevation of point D, this elevation, we start with 60. We add in our backsides. The backside is B and D. And we subtract off the foresight readings, which are A and C. So we got R plus B plus D minus A minus C, or 60 plus 87, 77 minus 72 minus 74. And that gives us 78 inches. So point D, the elevation of point D, is actually 78 inches above the monument.
But we're going to play it through for Blue.
Now, let's find the elevation of point F. Well, point F is, we start with our reference, which is 60 inches. We add in all the back sites, B and D, and we look at the pole reading at F, which here I showed to be 35 inches. That is, we have the pole next to this black pole, and we read on the scale that it's reading 35 inches. That is equivalent to a backside, because if we have the auto level set here, we'd be shooting back at the pole. So we add in B, D, and the reading on F, and subtract off A, C, and E. And that's what I've shown here. And by adding and subtracting all these numbers, we get that the height of F above the monument is 32 inches. Now, this might seem a little confusing. Basically, all you're doing, if you look at what's going on with backsights and foresights, we start at 60 inches here. We know that point A is going to be at 60 inches. So now B is above that by how much? Well, the gap between B and A. It's B minus A is that height right there. Oops. Yeah, change that to, let's make it black so it's more distinct. So this gap here is the height difference between B and A. So that's B minus A. So we take R plus, if you look here, B minus A, that's the height difference. Now when we move our auto level ahead and we shoot B, and then do on the backside, do a foresight to C, we know that C is going to be the same height as B. So now we can look at the height difference between D and C. D minus C is that gap distance. So we started with R at 60. We've gone up this height, B minus A. We've gone up another height, D minus C. That's what I'm showing you here. And then when we move our arm level ahead, we shot D, and we rotate 180 to shoot the point E. So E and D are going to be at the same elevation. And so what's going to be the height of F? It's going to be the difference between E and F and lower. Rather than adding, we subtract that off. So we're subtracting this height difference, E minus F, which is there. So if you add all these up, you can see that these numbers is we're adding in back sights B, D, and a minus minus F is a back sight, and then we subtract off our foresights A, C, and E, just as I did here. So basically, by adding in your back sight pole readings and subtracting off your foresight pole readings, all you're doing is accounting for these differences in heights in the gaps between when you've moved the auto level forward and backward. So that's basically all differential leveling is you're assuring that the auto level is in the center. You do a backside, foresight, that nulls out your earth curvature and reduces your refraction. So if you wanted to find, say, the 60-inch point by knowing the reading on E, and we know the height of E, the elevation above the monument for E, by going through the back sight and foresight readings on the pole, I can establish that E is actually 78 inches above the monument. So if I want to be at the same height or the same level as R, which is at 60 inches above the monument, I know I have to drop down 18 inches because E is at 78 inches. And if I drop down 18 inches, then I know that this spot here is going to be at the same height or the same level as the reference point. So that's basically it. So did Buster have something more?
Right. I think I should say, Blue, you did say that George did this for a joke to us. I don't think you knew. This is one of those things. Blue, George must have talked to you about this. There's no way that George made this presentation and didn't talk to Blue Marble Science about it. He came round here specifically because Mobius had asked Blue, how does differential surveying work? And then George turned up round here wanting to tell Mobius how differential surveying works on the globe, on the dogmatic globe. Not the real globe, the dogmatic globe. So, as far as we're concerned, it was Blue Marble Science that sent George round to do this. Now, nobody else wanted to do this, and nobody else has ever wanted to talk about this. This is geometric leveling, differential leveling, as occurs in reality. Well, the differential leveling procedure is what happens in reality. You might have seen it. It's how we know the elevations as marked on elevation profiles to relate it to reality. So all of these three lines here, they're all horizontals set by these auto levels that he's got as little blue things. Wondered what we've been doing? Well, this is what we have been doing. We've been trying to find out people. Well, I was trying to talk to Jesse Kozlowski, but Jesse Kozlowski did a Jesse Kozlowski. And then the guy that probably doesn't live in Maine made those videos and then couldn't talk about it. Slice Barcane can't talk about his bending water level test. In fact, nobody can talk about any of this stuff apart from George. So George is the best anybody has ever got. Now, I don't expect any surveyors to come into this arena because everybody knows what does happen to people, genuine people, whenever they come into this arena. This is the only recording of any globe, dogmatic globe Earth believer to have an attempt at solving the horizontal paradox. That's what George is trying to do right now. For Blue, I think. He was helping Blue up. This is the first time you've ever seen it. Oh, so this time, right, so, okay. Blue Marble says in the chat, this is the first time I've ever seen the presentation, Bev. Wow, that's surprising. George had lots of fun with you guys, but this time he was actually trying to teach us something. Doesn't appear to have worked. Right, okay, so Blue Marble Science is stating that this is the differential leveling procedure that would have to occur on the dogmatic globe model. Blue Marble supported. Blue Marble Science supported. Here we go. So it's going with George. This is what George was talking about. Here we go.
Well, nah, yeah, I was just wanting to hear you say. I saw the diagram, and so you can't get the difference of your foresight on a pole until you move up and do the backside to the former foresight.
Pardon? Run that again? Yeah, the height difference. I mean, the height differences. Yeah, you have to move. I mean, yeah, you have to do another setup. And now, of course, I could, if I wanted to take the time, I could have done this sort of thing. I'll mess up this diagram. Is suppose what I could have done is I could have taken the time and adjusted the height of the tripod and the tri-deck of the auto level and shot the same spot like that on that step, and then done the same thing, do the same thing here with this one. Then all I'm doing is following a level line. R has been transferred to here. So this height here, so this height here is going to be the same as this height here, as the same as this height here, if I happen to line up my marks, taking the time to adjust my tripod and the tri-deck base on the auto level so that I'm on the backside, I'm shooting the same mark as the same foresight, the previous foresight, then I'm guaranteed that this elevation, this elevation, this elevation, and this elevation are all the same elevation at 60 inches. But, you know, for sake of, go ahead.
Oh, that's fine. I get what you're saying. I thought at the beginning you said you were transposing the same height of M to F. No. What I wanted to do initially is find out what the elevation of F was. Okay. That must be my mistake. I thought you said you were transposing M to F. No. M would actually be right about here. If I were to transpose M, it would probably end up being right about there. Okay. Or no, it would be, I'm sorry, not there. It would be right on the green line. Okay. Yeah, that was all I had. That's it for me. If anybody else has any, I'll go on mute. Yeah. Get rid of that.
He's only just learned paint, I think, at this time. He's doing all right.
If I were to actually be transposing M, it would, when I'm all done, M would end up being there. So I was just trying to find. Well, back to the original, like don't they, like a lot of these tools, they say you can do a double run to get back to the same spot. Well, that's a different thing. That's a different thing. Oh, okay. That's for checking the instrument. Okay. Let me.
It's not for checking the instrument. It's for checking your whether you've got everything right. So you should always do a double run. You should always go back again to make sure that you've done everything correctly.
I'll get rid of this here. Hang on.
Don't know.
Let's say on what you're talking about is we're doing a top-down look right now. This is not. This is a top view. Let's say we start here, and we want to end up here. Okay.
Mm-hmm.
Now, there's really no set standard on this is how many setups you need to do. Typically, people do about 10 setups on a double run. And basically what it's telling you is that if I set up my auto level, say starting here at A, and I want to, so we start here on A, and we set up our auto level, and we say we have a pole sit here, and our auto level would be set in the middle. Let's just do our auto level sitting there in the middle, and then what we do is make notes of where we're hitting on the pole. Okay, we do pole readings at each step. So now let's just say, oops. Okay, I'm just going to set up a bunch of poles here. Okay.
Okay.
I think I just realized what the banging is.
And now,
go on, because I've been wondering what it is. Like,
it's. I think it's George moving his mouse on his desk, and the mic was picking it up.
Yeah, I think that's what he was saying. I was like,
yeah,
sounds like he's banging a cupboard or something.
Yeah, I think as George was going, because a lot of people don't have room on their desk to move their mouse, so they pick it up and then kind of slide it like this. Can you guys hear that? I don't know if you can.
Yeah, but not like that.
Yeah, well, if the mic is on his desk, it's going to pick up the reverb of it. I think that's what it is.
Yeah.
Yeah. So it might not be a wonder if you asked him about it and he was going, "What the hell are you talking about?"
Yeah.
Mm-hmm.
Yeah, his mic must be. Yeah, I don't know. He's learning all of this sort of stuff as well, though. I don't know what.
Got to cut him some slack on this stuff. I mean,
yeah, he's doing all of this on his own. Like, and if Blue says he's never seen this, then George has done this out of the way of blue marble science. Like, who was he talking to? Maybe it was Rumpus. He's got to have gone over this with someone. Like, he wouldn't just make this for us. And if he did, then, I mean, all credit to him. Blue Marble says we shouldn't be showing it. But this is something that George didn't show Blue Marble Science. He might be jealous. Nobody else has got this sort of display of globe differential leveling. And if he didn't show Blue it, then it's like I've been saying. The only chance these globers get to talk about their globe is when somebody challenges them.
Mm-hmm.
And then they get a chance to do this. George's legacy.
Absolutely.
Yeah. There we go.
This is one setup here. And this is another setup. The auto level's sitting in the blue areas, okay? I'm sorry, that this should be a black pole. Whoops. Crepe paint. That should be black. Okay. So we've got a pole. So here's our first set. We do a differential level. We
No, sorry, I'm going to have to stop it again. Blue, I said he hasn't shown it to you. You are the one that said you've never seen it. What are you talking about? You said he shouldn't be showing it. Who said that? You, Blue. You've just said that. I never said that. I said George has never shown you this. So this is a on the level exclusive globe differential leveling. You'll not see this anywhere else. George has never presented this to Blue Marble Science and the Blue Marble Science HQ. He's never presented this to Geos. He's never presented it to Gem Panda. He's never presented it to Fight the Flat Earth. He's never presented this anywhere. There has never been any documented display of a dogmatic globe differential leveling like this. And it's still unfinished. If anybody is out there, globe guys, dogmatic globe guys, you can help George solve this horizontal paradox problem, then please do. I did not say that Blue Marble said that George shouldn't present it. No matter how much George, Blue Marble's bullshit in there, I said that Blue Marble has never seen this. So watch it, Blue. Learn. If you've never seen it.
Mate, I thought you and guys knew nothing about shape. That's
What?
strange.
You what?
I thought you guys had nothing to do with Earth shape.
No, this is George doing differential leveling on the globe.
You guys aren't into shape or anything, so why are you talking about it?
Differential leveling isn't to do with shape. It's how you measure elevations. In reality.
You have to make sure your gravitational field is the same in both places, don't you?
No. Not doing a differential leveling. No.
You have to make sure your frequency is the same in this.
No, you don't. You don't. You just set up an auto level like this. Watch and learn. Or have you done any differential leveling? Have you done any surveying?
Well, I can sort my back garden out with a light and a cube, and that's sort of like an auto level, isn't it? Because it'll just display a beam in a straight line in all directions, wouldn't it?
A light and a cube.
You never seen it? Okay, so basically they came round and did my my front door, and to show you that the door was flush and all things like that, they brought out this box that you can just put anywhere you want and it'll auto level and show you your level laser in 360. So you can get your level in 360. So if you want to level off your garden, you can level off your garden because it'll just shine a beam 360 degrees. So if you want to do an level, you just do a bigger version of that and you can get to wherever you want, a mile away or whatever.
What, with bigger lasers? Or a bigger box?
I would still keep I'd probably still keep the gap as thin as possible. Therefore, the dispersion is going to be a hell of a lot less. But yes, maybe if it needs to be relative, then so be it.
If it needs to be relative.
No, as in related to scale. Like you were saying. Do you make it?
All of this every time we do surveying in reality, right? We do it at 1-to-1 scale. Always.
And if you ask a surveyor how far they could accurately measure with a theodolite, and most of the equipment they use, you'll find that it ain't that far. They'll just laugh at you if you think that you could pull off anything further than that, because he said it's impossible.
Would they?
It's surveys in general. Surveyors work with surveyors, work with surveyors.
Yeah,
they all do this.
Have you talked to many?
Yeah. I was in London and speaking to the surveyors there. They constantly are checking the levels of London because obviously things change and stuff like that, don't they? So if the ground is constantly changing, then our measurement last year or our measurement yesterday won't necessarily be our measurement today, will it?
Yes.
Because the conditions are different.
No, the benchmarks that are set have been set for hundreds of years.
I wouldn't say that because sea level is different everywhere around the world, isn't it? So sea level one place is not the same as sea level somewhere else. So in
the UK it is though. The mean sea level is entirely the same all the way across the entirety of the UK, Scotland, Wales, England.
Oh, totally. we can set stuff locally. It's very easy to set something locally, and then we have a mean. It's a bit like frequency with concert pitch. We have a mean concert pitch, but we also have the individual frequencies of every single area.
Well,
Just
for
like
elevations in the UK, we just have a mean sea level. Just one.
Yes, but that's just the UK, so we can't compare ourselves to anyone else.
But we are just talking about differential leveling here. We're not differential leveling across continents. We are sticking to local differential leveling here.
Sweet. Cheers, mate. Appreciate it. Cheers.
All right. Listen and learn how they do it on the globe.
Make a mark on our pole here at A, and we swing around
You're talking about the globe.
make a reading on
The
this
theodolite cannot measure accurately up and down. It can only measure accurately left to right.
We're talking about auto levels, and we're talking about differential leveling on the dogmatic globe here. That's what Georgie's going over.
Yeah, and you have to have exactly the same conditions and everything like that. The frequency has to be the same. Loads of stuff.
What frequency? What are you talking about? The frequency?
I think, if you could measure the frequency of your air, your elevation would be different. So if you could measure the frequency in the air, you could probably get a 25 hertz. You might get 12.5 hertz, but you definitely have to have. But the frequency is like 0.1 difference, from one place to another.
And would that affect the elevation?
It would affect the perceived elevation, not the elevation itself.
Not the actual.
Well, you can't measure the actual because you have to perceive it to confirm what the height is. But we
are measuring it with differential leveling. We are actually measuring the physical elevation. That's the entire job of differential leveling. That's why we do it. Just elevation. And I've never known anything to do with frequency of the air to be involved with differential leveling, at least. Is that what they were telling you when you were asking them, the surveyors? Or did you just make that up?
No, that's what I've been studying last week, that the concert pitch is a mean thing, but actually you'll find that each country actually pretty much has a different frequency. So the way they measured and set their concert pitch must have been based on something natural. Therefore, if their natural frequency in the area is different to their next door neighbor, therefore they have a variable that is not the same. And therefore that could, and probably could be proven, that magnetic birefringence, magnetic aberration, there's loads of ways that you could sort of discuss that.
Yeah. I don't think we can discuss it within differential leveling, though. I'm not too sure. In the air. Yeah, I suppose that would come in over distance, would it? Would that greater distances? Because you might want to talk to Blue Marble Science. He's the one that does big distance through the air. Frequencies and stuff. Have you ever had a word with Blue Marble Science? Ooh, let's go back with George. Differential leveling again.
The first pole. Okay, now we move around level ahead. And we do a back sight to shoot this pole and do a foresight to hit this pole. And we make a note of those marks in our logbook. Now we move around level ahead, do the same thing. We do a back sight to this pole, a foresight to this pole, and we know all the pole readings. So what they mean on the double run is you go out, say 500 meters, and you come back 500 meters, so you've got a total run of 1 kilometer. They say after doing all this, pardon?
Oh no, but you have to you have to add and subtract your height measurements, right? Like on the pole, when you do a foresight and back sight, you're adding and subtracting.
Well, what you do is you first, you can do it in real time, or you can just put it in your logbook and then do all the calculations afterwards, adding and subtracting, adding in your back sight, subtracting off your foresight. But you have a logbook and you write down all your back sight and foresight readings. And you go out to B and you go back to A. Now, what that spec means is after you've done all these 7.
Can you see my screen? I'm on live. We're watching a video. We're going live to YouTube. And if you click on my live within Discord, you'll be able to see the video that we are watching, that we're going over. So if it sounds a little bit quiet, it's because we're watching the video. Okay. Can you do it? If you know how to do that in Discord, do you?
Yeah, all good, mate. All good.
All right.
If you're very, very careful and you're real meticulous in setting up your auto level, that when you go back, once you come out to B, then you reverse the procedure. You set up again and start moving back towards A, okay, doing back sights and foresights. And when you get back to A, that spec, let's say it says a double run, 1 kilometer will be within 5 millimeters, let's say. Is what they say is that when you get to this point here and you do your last setup and you shoot the pole, that after you've done all your calculations, that the reading you get upon return, that reading will be no different than the initial reading by 5 millimeters. Okay, and that's pretty damn good when you're going out, 1 kilometer with all these different setups of doing back sights, foresights, and stuff. And if you had a perfect operator and a perfect auto level, then you would be hitting the same mark, right? As you started with.
So I mean, based off the diagram that you had, do you always subtract the foresight of one reading from the back sight of your next reading?
Yes. Yeah.
What if your auto level's in a divot and your back sight is below your former foresight?
Oh, here, hang on. Okay. What this does, when you add the back sight and subtract off the foresight, what you're doing is actually just subtracting these height differences. Okay. Now, if the height difference, let's say, let's take this one and say instead of when we set it up that we're shooting higher than A with on the back sight, that we're shooting lower than A, kind of something like that. Okay.
Yeah.
What happens? Let me get rid of this. Yeah, go away. Okay. What happens is when we add the back sight, that would be this number, and we subtract the foresight, we get a negative number, right? Because this one's lower than this, and that tells us that we just happen to be shooting lower. This distance, that if I start off at 60 inches, I got 60 inches, say, I'm starting off with 60 inches here, okay, on the reading on the pole. And this pole reading here was B, which is 87 inches, okay. Now, if I happen to set my tripod lower than that, so now I'm shooting below this, so that I'm shooting at this point, let's say I might be reading, say, 80 inches, okay. So if this was 87 inches, let's say here we've got 87 inches, and here we have 80 inches, that this is actually 7 inches lower, right? So our back sight is 80, we add that, and we subtract off the foresight, which is 87, so we end up with what? A minus 7 inches. So we start out with 60, we add in 80, subtract off 87, so we got 60 minus 7, or 53 inches. So it all comes out. So as long as you're adding in the back sights and subtracting out the foresights, the numbers all work. You know, if it ends up being...
What do you end up with at D and C? I mean, does it work out at the end? I mean, like what you've changed, will it still work out at the end at F?
Sure. Because now, let's say, my D, it's got messed up here. Crap. Here, let me just get rid of that too.
I find it hard to believe you didn't practice this.
So my D is still here. Whoops.
George, while you're doing that, can I just get a clarifier?
Yeah.
Is the double run, is that the same as closing the loop?
Yes.
Yeah, it's exactly the same principle, exactly the same.
Yeah, that's what they mean. Yeah, double run.
Right.
You go out and you come back. You're closing your loop.
And then closing your loop for accuracy of all your measurements over that run.
Right.
Yeah.
Yeah, basically what it is to check how good you are as an operator as well as how good the auto level is. I mean, there's two sources of error that can creep in. One is if your auto level is out of adjustment, and the other is how good are you as an operator in sighting the pole and estimating, say, between graduation marks and stuff, you know?
Right. Cool, thank you.
So it comes with experience. I mean, the more experienced you are, the less operator error that's liable to creep in, right?
Look at the experience that we've got.
Okay, so back to this is now, see, D was at 77 inches, but C now is going to be much lower in this case than 74 inches. It's going to be, you know, maybe down here at around 30 inches or whatever. So C is the foresight, D is the backside. C was 74 inches. Here's the numbers here. C was at 74 inches when it was up here. So now it's way down here. So,
but it's now it's 7 inches less. So 74 minus 7, 60.
No,
67.
No. It's only 7 inches left on this side.
Well, it would be the same 7 inches, though.
No, it won't. Well, it's at the same 7 inches with respect to something here, but not with respect to D. Oh, okay. No, you're right. I'm sorry. Yeah, you're right. Since this just dropped down 7 inches, you're right. This will drop down 7 inches too. Okay. My mistake. You're right. So C now will be at 67 inches, right? It was 74, so now it would be 67 inches, right?
Okay.
So when we subtract the backside or the foresight C from the backside D, we end up with a gap of 7 more inches, right?
Okay.
So it all works out, Buster, in the wash. I mean, as long as you note your pole readings down correctly in that by starting with your reference and adding your back sights and subtracting off your foresights, is if you study this section here that I did, is where we're adding back sights and subtracting foresights, and you group them appropriately, all you're really doing is either adding the height difference or subtracting the height difference, depending upon whether your next setup is shooting higher than the previous mark or lower than the previous mark. You're just adjusting for these height differences.
I was just wondering, like when we changed that, you went from 87 to 80, and then I was just wondering if you could work it out to the end, if it still ends up the same to F.
Well, let's look at it. Let's go through the numbers.
Okay, that'd be awesome.
We agreed that D hasn't changed, right? So D is at 77 inches, right? I'll mark it down here. This is 77. Whoops. That's 77 inches, right? And we've agreed. Oh, I'm sorry. Was it 77? Yeah. Okay. Pole readings are at 77, and this reading now will be at 70 inches, not 67. I don't know where the hell I came up with 67, but that will be at 70 inches, right? Because we dropped it. Or no, that's not right. Okay. Let's see. Our A was at what the hell? Oh gosh. Here, let me start over.
You still with us? Everybody's still with us? Everybody's still with us. George is... you still with George? You know what he's doing? Sounds like he's a well-experienced surveyor. And, like, who could have thought that he might have possibly practiced this? Blue Marble's never seen it. Yeah, I know. Mike, you're right. He should have at least let George go over it first to make sure he had it all sorted. Fancy going in blind without letting anybody of your mates know? Unless it was Rumpus. Unless he worked this out with Rumpus. I don't know. We'll never know.
I apologize.
Here we go.
Here. Hang on.
Let's
do what you wanted to do and go through it again.
Hey, good afternoon.
Hey, Rob.
Hey, you asked if we were still with you.
Yeah.
I'm in here. I had to jump in.
It's good hearing George again, isn't it?
I kind of miss the guy.
Yeah, I know.
You can sense the frustration in his own head. You can hear it.
Yeah. Yeah, this is what we call a nut sacking. This is what happens once you try and solve the horizontal paradox. In reality, like it's a real thing.
Yeah, you feel bad for him. Just struggling here. I don't know if would have helped if Blue had gone over this with him, or Wally had gone over this with him, or like you say, maybe Rumpus did. I don't know.
Yeah.
If Rumpus is listening, lurking, maybe he can say. But clearly, poor George was left to his own devices here.
Yeah, Jesse Kozlowski did a Jesse Kozlowski.
Mm-hmm.
The guy that probably doesn't live in Maine also did a Jesse Kozlowski, and they've left George here. And George, role playing, I think. Well, left to solve one of the unspoken of paradoxes solo.
And just for me, because I really didn't talk to George very much at all, and I'm kind of new to the whole arena. So, was George a surveyor? I just don't know. It's an honest question.
No.
Oh, okay.
No, he had some tools. He's a bit like that Jesse Gordon character. He's got a few tools. Yeah. I think George once told us that he did a calibration. He calibrated, but he seems to know nothing about a 2-peg test or actual calibration. We've talked to George about all of these things quite a lot. And
well, I will say I'm glad. Yeah, I'm glad to hear George was not a surveyor, because a surveyor struggling like this would be.
Yeah.
Yeah.
Well, I mean, it's hard enough for a surveyor to talk. Well, it's not really. It's dead easy for a surveyor. Go and listen to the Illinois surveyor. He'll tell you exactly how it works in reality. But this is special. This is dogmatic globe differential surveying.
Extra difficult.
It's really hard. And George is an experienced something in this arena, let's say. And yeah, at doing this. Again, I have to remind you that all of these red lines here, they're all horizontal, established by a level. This is leveling on the... You may ask yourself, how the... That doesn't seem right. Well, trust your instincts. This is dogmatic globe differential leveling. Here we go.
Okay.
Let's go again. Starting it again.
Okay, this is what we originally had. All right. This is Buster I'm talking to?
Yes.
Okay. Because I don't have the Discord up. I can't tell who I'm talking to. I just
That's okay.
go by audio. Okay. So this is our initial setup. Okay. Our A is 72 inches. Our B is 87 inches. So now we're going to move our auto level and adjust it. So instead of shooting high above A, we're actually going to shoot below A, right? We're going to do this sort of thing.
Uh-huh.
Okay. Now, let me clean this up a little bit.
He's obviously new to paint. I think I've never seen George with paint like this before. On the fly. Anyway.
He's doing fairly well. I mean,
I
because
know.
paint is not easy to do on the fly. If anybody's played around with that. There's a reason why that thing isn't out
So
there.
this is our D, and this is our C here. So D is still going to be the same as what it was. I haven't changed that. So we have to readjust our readings now for A and C. Okay. Now follow me on this to make sure I don't make a mistake. Okay, just clean this up a bit. Okay. So now our B.
Is anyone else getting deja vu?
I was just wondering if the process that you do would still work out to the same measurement you had it.
Yeah, it will. It has to. Yeah, of course it has to. Yeah.
Okay.
Because otherwise, what good would this be?
Right.
You know.
Right.
Okay. So our A is the same as was before. We're shooting the rod at 72 inches. Now, I'm going to put a new number here next to B so we can keep track.
He just
so
made those numbers
before
up
B
to
was
start
up
off
here,
with.
and we were shooting at 87 inches. Now we're shooting lower than A. Pick a number. A is at 72. Let's say, what, we said if we dropped it 7 inches below. Is that okay?
That's fine. Yeah, I think that's what you were saying earlier.
Yeah. So if we drop it 7 inches below, we're actually going to be reading 65, right? For B. So B now is reading 65 inches. That's what I've got there. Yeah. Are you seeing that in the poll readings next to it?
Okay.
Okay. So B is at 65. We've dropped how much? We've from the previous reading, we've dropped 22 inches, right? 87 less 65. B used to be up here at 87, so we've dropped down to 65, so we've dropped down 22 inches from what it was before. So we've dropped our auto level down 22 inches from the initial setup.
Okay.
So then that means C has to be lower than 22 inches than it was before. So C now will be 52 inches, right? If we're 22 inches lower.
Okay.
We've dropped B down 22 inches from where it was initially, right? So C also has to drop down 22 inches more from what it was. So if C was at 74, it now has to be at 52, right?
I'll be honest with you, George.
You don't see.
I thought that like when you set your auto level up, you just take the readings off the pole. It wouldn't matter.
Right.
It seems like it just seems like with the way you've got it set up, you're getting the cart before the horse.
No, we have to know what the pole reading is here at C. We just can't pick any random number, right? I mean, if the
agree.
Here, let me do this. Here's our auto level. Whoops, what the heck? Okay, here's our auto level site. Initially, our auto level site was there, right? So the difference from here to here was 22 inches. We dropped the auto level down 22 inches, right?
Okay.
Going from here to here is 22 inches. That's what we dropped it down. Because our new reading B is 65. B used to be up here at 87. So we've dropped it down 22 inches. Up here was 87.
Well, at this point, you'd have to change your equation, right? So, like if R plus B plus D. See, now you have to change your whole equation.
No, we don't. I'll show you why. First, we got to make sure we agree on the numbers here, Buster. Here. Let me do this.
Well, you can't say in your equation R plus B plus D plus F minus A minus C minus E. Well, the way you've got it set up, you'd have to change your equation because now you've got R to A.
No, it's backsides and foresights. It's backsides and foresights. It doesn't matter what the readings are.
RPD face.
Yeah, but if B is lower than A.
But it doesn't matter. That's what I'm saying. It comes out in the wash, Buster.
Yeah, but if B is like if you're going through this process,
it doesn't matter if B. Okay.
I mean, I get what you're saying. You lower that one reading, but in real time, if you use that equation and you go do 3 foresights and backsights, and I was like, if I took your equation, I would be messed up because if my 2A was lower than 1A and 3A, then I couldn't use that B plus D plus F minus A minus C.
Yes,
how could you if B's lower than A?
I'll show you. Well, let's look at what happens here. B, okay, doing this equation now, our B, rather than being
George
87,
is in his
65.
element here. He's loving this.
So if I put in here, $65, and our C now, rather than being...
See, when you listen to this, has anybody ever heard George more in his element than this? He's loving it.
Yeah, I think he's totally engaged, right?
Yeah.
I mean, he's fielding questions. There's no yelling. There's nothing.
Yeah, Buster's being nice. He's trying to do his best to explain it. And this is, I mean, it's a nice diversion, right? Because right in front of him there's a massive problem. But this, at least this bit, is easing him into it. And what have we been going? We've been going a good hour and something. So he's at home. This is, I mean, for all of the people that say that, you know, like Blue Marble said that we were horrible to George, then we weren't. I think we were friendly to George. I was, anyway. I told everybody, we've got to keep George nice. You want George to do this. George, this is where George is in his element.
Let's see, B, D, R, B, D, we got to. Our D hasn't changed, so that's still the same, 77. So we're subtracting off A. A is 72 there. And now we subtract off our C, which is 52. So that number there is 52. Okay. Now if we do that, let's add it up.
Did George just do a drum roll?
We got 60.
So. Well, that was you said that to him on his thing.
Yeah, but I think right there you
it can't be his mouse, can it?
That's 202. I have 35. That's 237. Now I subtract off 52. That's 185. I subtract off 74. That's 111. And I subtract off 80. Oh God, did I get the numbers?
He can get the numbers right.
I add right.
He might have got the numbers wrong. I mean, does it really matter?
No, but I think he thinks that. I think that's why I honestly can picture him doing a drum roll on his desk with his fingers because the numbers worked out and suddenly he was excited.
Yeah, the numbers worked out when he did it before, and now he's adjusting the numbers on the fly, and he's like, "Whoa, super mathematician!"
Yes.
Look at this.
C is 7. Oh, that's not C. I'm sorry. God.
See, it's complicated. This surveying.
So I got to move this over. This is.
I think George is the only one that's ever attempted dogmatic globe differential leveling.
Do you see what I'm saying here? Is C is 52. C is the second subtraction. So this is
definitely 52. Because this is nothing like what would happen in reality.
Now if I add them, if I start with 60,
actual surveying,
fantastic. Yeah,
I add 65, add 77. That's 202. Add 35. That gives me 237. I subtract off 72. That's 165. I subtract off 52. That's 113. And now I subtract off 81. That gives me 32. So we get the same number.
See, it's like he could be a darts player the way he did that.
Same number. Yeah. Nice.
I just always thought they went out and they, you set your auto level up. You got a pole reading, foresight, backsight, and then you would move and get your pole, foresight, and backsight. I didn't realize you would have to get your backsight to subtract from your foresight. I just don't understand how you would get your backsight lower than your foresight, like how you had it at the first. And how you would...
No, the backsight is lower than the foresight. On this one, the backsight was higher than the foresight.
Yeah.
The first time around.
Well, how would... you changed the numbers, but you didn't change the equation.
You don't change the equation.
Oh,
then it doesn't matter. No, you don't. No.
You would have to, like, if the way you got it set up now, you'd have to change your equation.
No, you don't.
See, RBD face all the way, same equation, always.
You have a record book, and you just record your backsights and your foresights. And then, when you're all done, if you want to get elevations, you add your backsights in, you subtract off your foresights. It doesn't matter what the... Okay. You have your log book, right, for doing the backsights and the foresights. All right.
Okay.
And all you do is record the pole readings in those numbers.
I think some of the YouTube chat might think that
if you're doing a backsight, you put it in the backsight
not interesting
column.
here.
If you're doing a foresight, you put it in the foresight column.
He's got to warm up. This is
you put all your poles
globe differential leveling. It's never been done before. You can't expect him to be full of flair. I mean,
no, for sure, but you can't. I don't think you can say it's not interesting. I mean, George is going all out on this. How do you say it's not interesting?
Nobody else has ever done it before. How could you say it's not interesting?
I know. I don't understand that. But to each their own.
Yeah. I think this is fascinating myself.
Foresight.
Right. And it doesn't matter if the backsight or the Go ahead.
But like in that middle, now that we've lowered that auto level,
right?
If you're adding in the force, adding in the back sights and subtracting.
And this is
the
Buster
sights,
trying to work it out
this
as
middle
well.
one at 2A, it's lower.
Middle one at 2A. Yes,
You know,
it is lower,
2A
but it
your
doesn't
auto
matter.
level's lower. So how does
Yes.
that equation still work if
Well,
your
because
back sight's
okay,
lower than your foresight?
because
Buster
of the
doesn't
fact
understand
that
its RBD face.
what by adding and subtracting back sights and foresights, it is if we're subtracting the back sight off or subtracting the foresight off the back sight, what are we essentially doing? That is at this point, if we take the back sight marking here B, which is lower than A, and we subtract A from B, we get a negative number, right? B, in this case, is 65 inches. A is 72 inches. So if B is below A, we're going to end up with a negative number, are we not, Buster?
Yeah, that's fine, but you don't know for sure. Like your next rod sighting could be a whole different. Like you could have another divot at C and D.
Yeah,
that rod could
it
be
doesn't matter.
higher or lower.
See, this is differential leveling. It's subtracting. You're subtracting a backside or a foresight from a backside at each rod. This is what differential is you're subtracting. Differential means subtracting. So it doesn't matter. You could raise this whole pole up.
Differential means you're noticing the difference between the levels, quite simply, because you're starting off with an elevation and then you're noting the differences between the levels to transpose that benchmark from one side to the other side. That's all you're doing.
Up or down.
In reality.
Say if this pole were in a divot here, Buster.
Yeah, and as I understood it, again, I'm not a surveyor for sure.
Right now we have two readings.
But as I understood it, you had
D, we're reading
all the levels would be parallel.
And C, we're reading
right? Some would be
52
higher, some would be lower, but they'd be parallel.
Now let's say the pole's in a hole.
That's how I understand it in reality.
Down here.
Yeah.
This is
now each of these readings will change or be
dogmatic
by the
globe.
Same amount. If this pole moved from here to
yeah,
here
I would think
by
it would be
10
problematic
inches, then both
going back sighting and foresighting, because don't you have to go up and then down and then down and then up the curve?
Well, so what about if you were going to do?
Yeah,
the
no wonder why
double
then.
where you
No wonder why
have,
it's confusing.
I think that's the reason why there's only ever George that's done this. Everybody chooses to forget about it as a boring thing, a topic.
Yeah,
I'll be honest with you. To have horizontals all switched, and you've got to subtract your back sight from
George is just attempting to do
I don't know, that just seems crazy.
differential leveling.
No,
this is basically Jackie.
Okay. Well, that's